Okay, so earlier this week, we learned to classify three kinds of reactions or equations. And remember, equations are symbolic representations of actual chemical reactions. Chemical reactions are the things that actually happen with the chemicals. Equations are ways of representing those to explain what's going on. The three kinds of equations we learned to classify earlier in the week were synthesis, decomposition, and combustion. Now, we spent a little time talking about single replacement. We're going to go over that again. And I like to call it single displacement. And then we're going to go over double replacement. So, excuse me, the general form for single displacement looks like this. We have a very simple elemental substance. It might be a metal or it might be a halogen. We're going to start with the way it would behave if it were a metal. And we're going to react if a reaction occurs at all. We're going to react the metal with a compound that contains a metal ion. B would be the metal ion. And metal ions then are going to be combined with an anion, something that is negatively charged. And so what's going to happen is the element A, remember this is an element, will displace B because it's like B. B is a metal ion, A is a metal. A kicks out B. If A kicks out B and joins up with C, we get AC. And since A kicked out B, B is by itself. Now, another form of single displacement would look like this. When we start, it's kind of the same. But in this case, A is a halogen. If you don't recall, metals are all the elements on the left-hand side, from the stair step to the left. All these elements are metals. Halogens are all the elements in this column right here, and only this column. So if A is a halogen, A is not going to displace B. That's what happens with metals. If A is a halogen, it's going to displace C. So A will kick out C and join up with B. And that means that C is by itself. Okay, so this is a metal to metal displacement. This is a halogen to halogen displacement. Okay, so let's do an example or two here, and then I'm going to let you do some practice. So here is an element that's by itself. If you don't know what that is, you need to use your periodic table and figure it out. This is copper, and since copper is on this side of the stair step, it's a metal. Metals are solids with the exception of mercury. Mercury is a liquid. At least at normal temperatures it is a solid. And let's react that with this compound, which contains a metal ion. Okay? So this is a metal ion. This is, if you don't know, look it up on the periodic table, silver. Okay? and it's bonded with chlorine. So this is silver chloride. And this is going to be dissolved in water, so it's aqueous. Now, if a reaction like this occurs, the metal displaces the other metal, like A displaced B up here, metal to metal displacement. So C then joins up with Cl2. Or actually joins up with Cl. We don't know for sure how many chlorines we need until we balance it, but I'm going to go ahead and give you the formula. Copper here is going to be copper 2. That means it has a 2 plus charge, and we need 2 chlorines to balance that out. Copper 2 is also aqueous, and since copper displaced the silver, silver now is by itself. Now, I haven't balanced the equation with an atom inventory. That is required, but just so you know, this is already balanced. I'm just doing this as an example. Now let's look at an equation where we displace the halogen, where A is a halogen and B and C is a halogen ion. Well, it turns out chlorine is a halogen ion. So let's do this. So this is fluorine. If you didn't know it was fluorine, you look it up right here, F, fluorine. And we're going to react it with this same chemical. Okay? If halogen is going to react, it's going to kick out the other halogen. So what happens is elements in signal replacement reactions displace other ions of that same kind of element. So elements displace things they are like. Metals displace other metals. Halogens replace other halogens. So F is going to replace or displace Cl. You don't automatically assume it's going to be AgF2. You're just supposed to, you need to balance the formula. But I'm going to go ahead and tell you that's F2. And that kicks out the Cl, and it's going to be by itself as a gas. Okay? Now, you don't automatically assume you have these subscripts either, but most of the time with halogens, that is what happens. All right, so that's a kind of single displacement reaction. That's the way it appears. You have to be able to recognize, do I have an element by itself, and is there an element in a two-part compound that is like that element? And then if that second element in the compound that's like the first element that's by itself is kicked out, then you have a single displacement reaction. If you have a halogen, and there's a halogen in the formula of a compound, the halogen kicks out the halogen, and the halogen that was by itself joins up with the first part of the compound, then you also have a single displacement reaction. Now, what I'm going to do is give you some equations. So far we've learned about synthesis, decomposition, and combustion. Now today we've learned about single displacement. So you'll have a series of chemical equations. It might be synthesis, decomposition, combustion, or single displacement. And you're expected to classify them. Okay? Just to quickly review, synthesis is where you have two simple compounds that become a more complex or larger compound. Decomposition can be thought of as the opposite of this. We have a larger or more complex compound that becomes two simpler compounds. Okay? We don't have a really good general formula for combustion. We're going to be using a simple type of combustion reaction where there will always be some kind of hydrocarbon. A hydrocarbon contains carbon and hydrogen. What we don't know is whether you have one of these, or 5 of these, or 4 of these, or 17 of these. Okay? You just don't know. Well, it wouldn't be 17, 12 of these. If it was 5 of these, it would be 12 of these. So I'm going to put X and Y here just to show we don't know what that's going to be. What we also don't know is what its physical state is going to be. Some of them will be gases, some will be liquids, some will be solids. But this hydrocarbon always reacts with atmospheric oxygen. O2 is atmospheric oxygen, and it's always a gas. And the product of this reaction between some kind of hydrocarbon and oxygen is always CO2, gas, and steam, which is water in gas form. All right, so this is the form of a combustion reaction. Now, the teacher will show you the worksheet for you to classify these equations.